All right, hi everybody. I'm going to do the first three on the nines, number 5 FRQs. I hope you can see this okay. Thank you. All right, we'll see how the lighting is here. All right, so the first one says, this is all based on the same problem, which is kind of cool. So the problem says, I want to have this infinite series right here, and we're going to use the same series for problems 1, 2, 3. So all three of these will actually be from the same set. All right, here we go. If you find the interval of convergence by the absolute ratio test, remember, we want to do the limit as n approaches infinity of the n plus 1 term over the nth term at absolute value. So I'm going to do my absolute value of n plus 1th term, which will be an n plus 2, an x to the n plus 1, a 2 to the n plus 1, but that's all over the n plus 1, x to the n over 2 to the n. Now, remember, what we want to do here is we want to like simplify and cross multiply and all that kind of stuff. So the n plus 2 does not need absolute values anymore. I'm still taking a limit. I should write that at every stage. This absolute value of x to the n plus 1 is actually absolute value of x to the n plus 1. Remember, when you have the same base and different powers, you can split apart your base. Same with 2 to the n 2 times my reciprocal of that. So the 2 to the n is coming up. The absolute value of x to the n is underneath, and so is the n plus 1. Now, interestingly enough, the 2 to the n's cancel out. The x to the n's cancel out. This n plus 2 over n plus 1, the n plus, I'm going to do this kind of scoopily. That part, since I'm taking a limit, goes to 1. So all I'm left with is the absolute value of x all over 2. Now, let's make sure I didn't lose anything. Okay. Good news is, since I'm doing the ratio test, my answer needs to be less than 1. So this means the absolute value of x has to be less than 2, which means I'm in between -2 and 2. Now this is good news, because now all I got to do is test the endpoints. So if I stick in a negative, this is called my interior interval of convergence. If I stick in a -2, I get n plus 1 over 2 to the n times -2 to the n, but something interesting happens here. I've got this n plus 1, -2 to the n is -1 to the n, 2 to the n over 2 to the n, which goes away. But you're left with this like sign flipper n plus 1, plus 1, minus 1, plus 1, minus 1. This will be an nth term diverger. No good. If I stick in a +2, even quicker, because I'm going to get this n plus 1. I'm going to get this 2 to the n, 2 to the n, those go away. I'm just going to be left with the series n plus 1, but that's just 1, 2, 3, 4, 5, 6, going up to infinity. So my interval of convergence is my interval of convergence is -2 to 2, open. Now, write the first 6 terms of f prime. Now, interestingly enough, f prime is just going to be the derivative of f. So if I've got f, I want to make sure that yeah, this is good. Okay, so if I've got f, I want to make sure I just take derivative term by term. Now you could also, if you felt like it, take the derivative of the nth term. I'll talk about that in a minute. So if you just write out your first few terms of f's going to be, so we're going to stick in a 0. X to the 0, 2 to the 0 is a 1, 0 plus 1 is 1 plus. All right, now if I stick in a 1, the 1 goes in, 2 to the 1, x to the 1, 1 plus 1 is 2x to the 1 over 2 plus. Remember, don't simplify. You lose patterns if you simplify. Let's stick in a 2. 2 plus 1 is 3, x to the 2, 2 to the 2, plus 4, x to the, I'm thinking 3 over 2 to the 3, that's a 2. plus 5x to the 4 over 2 to the 4 plus 6x to the 5 over 2 to the 5. First 6 non-zero terms, 1, 2, 3, 4, 5, 6. But looking ahead, I noticed that if I take the derivatives of these, that one's going to drop out. So I need one more. And it's 7x to the 6th over 2 to the 6th. Now, that keeps going. I need the general term too. And we know the general term of this, of course, is n plus 1 x to the n over 2 to the n, because that's what made it. Now let's think about something for a minute. If you're taking f prime, you're just going to take the derivative term by term. Well, the derivative of 1 is gone, but the derivative of this is in essence 1, is 1x is 1 plus, but then the 2 is going to come down. I'll do the 3. The 3 over 2 squared times 2x. The 4 over 2 cubed times 3x squared. The 5 over 2 to the 4th, 4x cubed. The 6 over 2 to the 5th, 5x to the 4th. I don't really need to look anymore because I see the pattern. 1, 2, 3, 4, 5. I need one more. Plus the 7 over 2 to the 6th, 6x to the 5th. Now look, my nth term, you're like, oh, I need to see a pattern. That's a 3. When that's a 3, that's a 4, that's a 4, that's a 5. When that's a 4, that's a 5, that's a 5, that's a 6. But the thing is, of course it is, because your derivative of this is n plus 1 over 2 to the n times, and what's your derivative? N x to the n minus 1. So there's your n minus 1. There's something with one more, with two more. You're something with one more, with two more. And there's your general term. There's your f prime. I guess you could clean that up a little bit, but it'd probably just be very similar to that. Okay, good. Now, we're at the first 5 non-zero terms that represent f of 2x, given that h of 0 is 1. And we've got to be a little bit careful here, because f of x is this. So I would really like to integrate f of 2x, right? The 2x is 1 plus. Now, I'm going to replace every one of these. So 2 over 2, 2x. You're going to notice that I'm not really simplifying. I don't really want to simplify. I don't want to lose stuff. I don't want to lose patterns. But to get the first 5 non-zero terms, I really just need 5 of these, because each one will integrate. Although, although this h of 0 is 1, maybe I only need 4 of these, because this will turn into an integral. All right, this is going to be good. Plus, I got to think, this is 3 over 2 squared times, now the, shoot, I got to remember, I haven't integrated anything yet. 2x squared, plus what I say, I need a 4. 1, 2, 3, 4. 4 over 2 cubed times 2x cubed. Okay, so now, if I'm going to integrate this, term by term. This one will produce an x. But this guy will produce a 2 halves. Now, let's think. This will become, I know I could say a 2 and a 4 and an 8, or a 2 and a 2 squared and a 2 cubed, but I really like the fact that this 2x will be raised to the 2. There will be a 1/2 in front of it, 1/2 something squared. That something would have a derivative times 2, but I don't want. So I'm going to multiply that by a 1/2 again to undo the chain rule. We'll check this in a second. 3 over 2 squared. Now, the integral of something squared is 1/3 something cubed, but that something has a 2, and I don't want the times 2, so I'm going to put a 1/2. The 4 over 2 cubed is something to the 3rd, is the integral of something to the 4th, 2x with the 1/4 x to the 4th with the 1/2. All right, there's a lot going on here. Okay, hold on. But h, this is h. H, when I stick in a 0, better equal 1. When I stick a 0 into all this, gone, is equal 1. So it's going to have a 1 plus at the beginning. That's like my plus c. Now, if I want to clean this up a little bit, well, and by the way, if you want to check this, if you want to clean it up a little bit, this is 1 plus, now this is just 2x. And what's the integral of 2x? X squared, which I'm hoping this is. So you go to 1 plus x plus, I guess I will clean it up just a little bit. This is like 2 times 2 squared x squared over 2 cubed. Wow, there's a lot of 2s. I really want to cancel those out, but I'm not going to. There's a 3 and a 2 cubed. And there's a 2 squared and a oh shoot, I asked for a general term. And a 3 and a 2. And a 4 over a 4 and a 2 to the 4th and an x to the 4th. Oh, there's x cubed there, I forgot. Over 2 to the 4, 2 cubed. 2, 4 and a 2. Whoa, that didn't clean anything up. All right. Yay. Now, hold on. God, this is messy. All right, let's think for a second. 2, this is 8 over 8. This is just 1 plus x squared. That's weird. These guys, if I think the 3's go, it might be okay. 2, oh my gosh. 2 cubed, 2 cubed. No. 2 to the 4, 2 to the 4th, 4. I did not know this was going to happen. What the heck? That's kind of crazy. Okay, hold on. I got to think about this. My original problem had an n plus 1 over 2 to the n, but now it's a 2x to the n. Heck yes. Check this out. So this, I'm as surprised as you to see this. 2 to the n, x to the n over 2 to the n, and the 2 to the n's cancel out, and all you're left with is n plus 1, x to the n. Oh, shoot. This should have gotten 1, 2, 3, 4. Oh, because that's f of 2x. So now I'm going to integrate it, and the integral of this is n plus 1 times x to the n plus 1 over n plus 1, because that's what you do. And these are go away, and yeah, that is actually really cool. Okay, I'm going to pause these videos after every 3, but this is 9's number 5, FRQ 1, 2, 3. Now, shoot, can somebody bring me a colored? Oh, I got one right here. Okay, so now what I'm going to do is like grade this or something, or give me some points on this. So if I think out loud about this a little bit, this first 3 would go like this. This would be like 9, actually. So probably sets up ratio test correctly, gets the result of ratio test. Sorry, this. So this is your second point, your first point. Your third point would be to test both endpoints and get towards here to be your third point. There's 3 there, okay? Sort of making this up as I go along, but that's okay. My first 6 non-zeros and the general term, blah, 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 like that. Now the cool thing about this is that's going to be 1 point for your general term. That works. This probably will be something like, this would be more than 3 points, but we'll just go for this for now. Writes out general term, 1 point, integrate or derivates term by term. Okay, technically though, this would be like 1 point for this series. You probably get like a point the first couple, a point for the next couple, something like that. But just for this, for grading purposes, we'll go 3. Now this guy, I kind of want to see like this general term, even if it's like unsimplified or simplified, this is like 1 for your general term. But this guy here, you really need to have some sort of work for your either your f of 2x that you're about to integrate to get to. And by the way, either one of these is okay. Some sort of unsimplified. And then if you want to do this, I just think it's kind of cool. I should have made the question show that it is, and that would have been fantastic. And I did not anticipate that happening. But there would be out of 3 for each, and be kind of cool to see what our score out of 9 would be for the first 3. So that is questions 1, 2, and 3.